Hello, here is a complete working circuit of a dual converter. In this we have 8 silicon control rectifiers, SCRs, 4 for clockwise and another 4 for anti-clockwise. That means this forms a bridge, this also forms another bridge. While this is a bridge, this side is positive and this side is negative, and supply is given here, AC is given here. Similarly, AC is given here. PQ means P is actually this, Q is this, so the supply, same thing PQ, these are actually connected, but the software permits us not to make it complicated just by giving some numbers. So we get that the AC supply is available here and we get DC here. Of course it will be pulsating DC. We connected a load here and this is the ground point we have taken. So while it is in clockwise, we will find this side is positive, while it is in anti-clockwise, we will find this side is negative. So this is what is how a dual converter works, and we will see while we operate this and for its functioning. So this is the waveform that we get. These are our 0 voltage pulses, which as per the scale here 2 millisecond we find 5 divisions. So every 10 milliseconds we have a 0 voltage pulse, and the triggering pulse to the pair of SCRs are of course the alternative way, and this is what is given. And then finally we get negative pulsating DC here. This is the output. These are the triggering pulses and this is the output. If we look at the diagram here, what we find is this side is positive, that is ground is positive, and this is negative because this is in the anti-clockwise, and 0 voltage is given here, and we have taken some sample signals which is given to the opto isolator here for either this pair or this pair. This is how a bridge works, bridge rectifier works, and by changing the pushing here we can change the firing angle also, and in the process we can control. And for clockwise we get this kind of waveform, positive with respect to this is the ground, so this side is positive because this 4 SCRs are being triggered to give you this kind of pulses. And as usual, this is the 0 voltage pulse, and these are the triggering pulses to the pair of SCRs. That means this is for this and this one is for this pair. Of course they are all driven by opto isolators. They are MOC 3021. One can also use MOC 3061, 63, 66. They can also be used, and this is a PIC microcontroller on which it has been done. And we have a switch here for anti-clockwise and clockwise, and a triggering angle change also. We can change the triggering angle so that we can see how the pulses would also change based on that. So once we take the triggering angle here, what we find that the triggering angle will be delayed, and then this is how the triggering angle delayed, like this is 0, this is delayed by this much of time, so you get the waveform not conducting from here to here, and then the waveform is like this. Similarly for this, the pair, other pair, it conducts like this. Now if you could see it here, this for the this side is what you have noticed is this is negative, because B, we have mentioned B here, this is positive, so we get positive pulses here, and so this is triggered by this kind of pulses, and this is triggered, these two are triggered by these kind of pulses at a difference of 20 millisecond, and these are the 10 millisecond difference 0 voltage pulses which we give to the program for working. And this is how a complete dual converter with control, also power control, is possible. Thank you.